doing. And you can give us maybe a little teaser about what's going on at MoFI with respect to your new speakers when they're coming out. But do you want to just, I mean, do you want to just start at the beginning and kind of what you were thinking when you joined MoFI and what the opportunity is for you?
Yeah. It was interesting because we'd been discussing the possibility for quite a while. And when I was at ELAC, we were a full speaker company. And so pretty much everything we do is speakers. We added some electronics to it, but it's mostly a speaker company. And we've got lots of ranges of speakers, and I always seem to be designing a new one. And it was often very difficult to decide at any given show which of the various models that I've done should we demonstrate. You know, do I demonstrate even within a range? I've got the bookshelf and the bigger bookshelf and a floor stander and a bigger floor stander, and you can't demonstrate them all. And I want to show value and possibility, so I always tended to show one of the small bookshelves to show how good it can sound when set up right, and also how good bass you could get from a small speaker. And someone once commented, we don't seem to be selling many subwoofers. I'm going, that's because I never demonstrate them, because I'm always trying to show how good the speaker itself is. And so you're in this dilemma of, you'd maybe think, okay, well, maybe I'll demonstrate one speaker at one show, and the next show I'll demonstrate another one, except these are all mostly regional shows. And so when you get to the next show and you demonstrate a different speaker, you'll always get people coming in, oh, I came here hoping to hear the speaker that showed at the other show that I couldn't get to, but everyone was talking about. And so you get locked into, maybe I'm only demonstrating that one ever this year, and then next year I'll demonstrate something else. But that's always going to happen with a speaker company per se. You're going to have lots of speakers and a plethora of choice of which one to do, and how do you pick and choose what to show off. MoFi is different. MoFi is not a speaker company. It's a company that's going to have some speakers. And that's a very important distinction. Yeah, we want to grow the speaker section of MoFi, but right now we're not thinking of lots and lots of speakers. You know, MoFi do the records. MoFi have MoFi distribution, which brings in, interestingly, Wharfdale and Quad and Piega and Hi-Fi Rose and all manner of other products. There's Music Direct as part of the group, which is the direct sales division. But MoFi distribution distributes to all the independent retailers. But we also have manufacturing, which obviously we got the MoFi turntable, the latest one of which was the Fender edition. And so their vision was, well, why don't we work towards having our own complete system? You know, if we believe in what we're doing and what sound we're trying to get, could we have a complete system that represents that? So turntables with the Arm and cartridge, some electronics, and some speakers. And then it became interesting because even though they'd been considering doing speakers, it's the same old story. Who needs another speaker company? Who needs another speaker brand? There's always too many speaker brands. And I was just discussing before the meeting started with Bill about this, that whenever a new speaker company starts up, people go, we don't need another speaker company. And I've been sort of caught myself saying that. Who needs another 6-inch two-way, right? as kind of the most common speaker. But the answer sort of is there's always been lots of speaker companies for the last 50, 60 or more years. It's just that the ones that we have now are not all the same ones that we had back then. Speaker companies come and go. Some rise to the top, some sink out of view. So there's always change. So there's always a chance for new people to come in and establish themselves and take over to be one of the preeminent brands. So it shouldn't stop. If you really think you've got something to offer, then it shouldn't stop you giving it a go. And so MoFI were interested in the idea of doing this. And after some discussion, when it proved that I was interested in doing this, we then started thinking, okay, so what should we be doing? So that's the first part of joining, was how do we represent part of the spirit of what MoFI want, what the market wants right now, and what I want to do. Because I get close for the last 40 years, I've never been in a situation where a marketing team has come and said, we want a speaker that sounds like this. We want you to build something and then we'll listen to it and tell you what needs changing. I've never had to do that. There was only one time where it almost became a possibility. One of the marketing guys, when in the later days of Infinity, I mean, later days, I was only there 3 years, but they said, you know, we're thinking about doing something more in line with the old style Infinity. So we want it to sound more like an older style Infinity, a classic one. And I go, okay, tell me what that is. This was my deflection away from having to do this. It was, tell me what an old Infinity sounds like. And they came up with these descriptions and go, aren't those pretty much the same descriptions everyone claims to have in their speaker? You know, resolving, impactful bass, low bass, smooth treble, whatever the words were. I'm thinking that doesn't give me any clue as to specifically what you're asking for. And I was able to just punt it until they gave up and leave me to continue designing what I want. And I know that always sounds a big-headed statement, but it's very difficult, I think, to do a complete design when it's not something that you yourself believe in. If you're just doing it to please a certain market sector, it's much more difficult, because if it doesn't sound like you'd want to listen to something over, how do I know that I've achieved my objective? Now I've got to present a design to some marketing group that then takes it out into the marketplace and gets feedback. It just, I can't really work like that. My marketing feedback is going to all the shows. I like people to talk to me about what they're experiencing, hopefully saying nice things. But certainly one of the things I've always enjoyed doing is taking prototypes out. That's my excuse for saying I didn't get it finished in time for the show. So by taking out, hopefully a close to finished prototype, if people like it, I go, yeah, and it's only a prototype. Think how good it will be. If people don't like it, yeah, well, I mean, it's a prototype. I haven't quite finished it yet. You know, there's some changes I can make to it. But basically, I do like people to give feedback, whether good or bad. And I don't have to change it based on one or two people saying something, but I'm always happy that they can do that. There's a couple of instances I always remember where at one show, some guy walks up to me to talk about how I design speakers and what my concepts are. And he flat out told me I'm wrong. He went through all the features that I incorporated in my speakers and say, that's really not the right way to design speakers. And I just let him talk. I didn't challenge him on it because it was clear he had his views and I had mine. And it's not that all those views were wrong in my view. They were just different from what I choose to do. And if you look at the marketplace, there are lots of speakers that are different from mine. And even if you take one concept was, as you get better and better speakers, more and more costly speakers, the real high end, shouldn't the sound converge to some common, this is what real sound should be? And yet we don't find any more convergence at the high end in concepts. In fact, maybe there's more divergence because you can afford to engineer very different things to small market segments. Because it's costly, you've got a smaller market, maybe there's still enough people believing in different concepts that you have a business for your particular concept. If I'm designing a $100 speaker, I need to sell 100,000 or more of them. There I have to hope I've got 100,000 customers for it rather than 10 or 100. But you know, there's sufficient divergence in what people want. And so when someone comes up and say, I'm doing it wrong, there's a better way of doing it, I just listened to him. And when he finished, I could tell he was waiting for a challenge back. And I thought that would be a futile thing to do. So I said to him, you know, I'm really happy that you were able to come up and tell me that I was wrong in pretty much everything I'm doing. He gave me this really strange look. And I said, no, really, I'm happy that you felt comfortable enough in approaching me and telling me what you thought that I was doing wrong, that you were able to do that. I welcome that. It doesn't mean I'm necessarily going to change my view, but at least hearing other viewpoints can give me food for thought. And I may incorporate some of that thinking or I may not, but at least you felt comfortable in doing that. So thank you. And it kind of just, it kind of killed that challenge in a way, that kind of attitude towards it. And then one other time, my room had cleared out because I was next door to Wilson and they got time demonstrations. And I think some people had only come into my room while waiting for the time demonstration with Wilson next door. But, you know, they were listening and then they'd go out. The room cleared out and there was one person stood at the back of the room. And I said, please come and sit and listen. And he said, oh, no, I couldn't possibly do that. And what do you mean? He said, the way you've set up the speakers, it's all wrong. And how do you mean all wrong? So I'd got the Pioneer EX speakers, which were basically mini-me TADs. And because they're concentric drivers, I spread them far apart and then across the axis so they point in front of the listener rather than at or behind. Because with concentric drivers, you never point them directly at you. In fact, I'd argue sort of even almost with any speaker, the point of maximum symmetry of diffraction effects is dead on axis. And so always listen slightly off axis, whether it's in front or behind you, but particularly for concentric drivers. So he said, it can't possibly work like that. I said, you know, if they were regular type of speakers, I would say, yeah, that's not the way to set them up. but these are concentrics and they have a particular off-axis performance, which the image is enhanced by doing this. You know, come and have a listen. So no, look, I promise you, look, you don't have to stay. All I ask is at least listen to one piece of music, and if you still think it's set up wrong, fine, you know, you can walk away. So he did actually sit down for half an hour while I played nearly a dozen tracks. And at the end, he said, I have to admit, that sounded really good. And so I said, I thank you for at least accepting to try and listen. That's all I ask for. You don't have to like what I do, but at least listen to what I do so you can properly make up your mind rather than having a concept of what you think I've created without the experience of listening to what I've created. And so we shook hands and off he goes. So it's fortunate that, as I say, I've always had the freedom to be able to decide what my speakers should sound like. And an important point about having joined MoFI, you know, I've known the guys from MoFI for a very long time. You know, they used to sell the Pioneer speakers through Music Direct. They've sold all the ELAC. In fact, MoFi or Music Direct were the first people to pick up the debut speakers, the ELAC debut, when I first introduced them. They walked into the room, amazed by the sound, and said, we want to sign right now to sell these speakers. So they've always trusted in what I do, and the idea of approaching me, that they'd already been thinking about speakers, but if it was me doing them and they trusted my vision of what speakers should be, then that would make a great team. And so that's what ultimately decided me to join. And with the idea that it's not creating speaker after speaker after speaker and confusing everybody about, well, which one should they get? And is a debut reference that's near the same price as the Unify Mark II, but not the Unify reference. Which one should I pick? Because they're all kind of in the same price point. It can get difficult. I don't think that's going to happen here.
Yeah, so a few things. I do want to talk more about that. I did notice you were very productive at ELAC. You did design a lot of speakers. you were really, really busy. And so when did you start with MoFi? How long ago?
I actually joined January of last year. So I've
21.
been of 21.
Of 21. So you've been designing how many types of speakers for the last 19 months? One
well,
type of
let's say there's three. There's going to be three to begin with. One to launch first, another to follow, or the other two to follow in different categories a bit later. But the concept, the primary concept of what I've been doing has taken, well, I say nearly 18 months. Yeah. So I've done pre-production. I've checked them off. That's why I was in Vegas last week, measuring them all and checking that they're all okay. So we're moving into production. So before the end of the year, they'll be available to purchase, basically.
And what price point? Can you tell us around?
More than ELAC.
Are they bigger than a bread box?
Thousands rather than hundreds, let's say. But and the announcement's going to happen probably early November, I should think. So
or now. Feel free to share your among friends.
Turn off the recording. So it's not all been, it hasn't taken all this time just to design the speaker. of course, it's a new company for me, new facilities. Even when with ELAC, I had to start up a new office, build a new lab, build a listening room, build a measuring room, and that takes time. And with MoFI, of course, MoFi are headquartered in Chicago. And when I was talking to them, I was going, you do know I'm not moving to Chicago, don't you? But also, I needed somewhere to work from. And with ELAC, it seems everywhere I've worked is way away from where I actually live, and always been driving a lot of miles every day. So even when we started ELAC, and we sort of had a free choice, but all the other guys that started with me, they're all Orange County people, and I'm north of the Orange Curtain. And so driving down in the morning is sort of practical. Driving up north in the morning is next to impossible. So once again, I ended up, I'm the sacrifice. I'm the one who has to do all the driving. So I determined that this time, since there's only me to please, because it's only me, the only person who's designing speakers is myself. And so I said, I really need somewhere closer to home. And so I went looking around to see where that should be. I said, I'm not driving 40 miles each way. And my first thought was, since I live in the middle of West Hollywood, if I go to the bottom of my street, it's Santa Monica Boulevard, and I just keep going and I get to the sea. And I'm thinking, wouldn't it be nice to have an office overlooking the ocean? That would suit me. But other than cost, driving back there in an evening can take 2 hours for 8 miles. So I wasn't going to do that either. And eventually I found this facility, which I'm in now, in Beverly Hills, of all places. 90211, one better than 90210. And, next door to Nobu Matsuhisa's original restaurant. So it's so easy when important people visit. We just walk across the car park and we can go to Matsuhisa. So it's a fantastic location. It's walkable from my house. It's 8 minutes drive, and it's me. I'm setting up this place to suit me, and not had that before. So I've got a beautiful, well, it will be a beautiful listening room. It was working quite well until last week when we pulled everything apart to repaint. But we're getting ready. By the end of the month, this whole place will be finished. I'm custom building some absorber panels. I've got some nice furniture. I've got all these bookshelves for diffraction and diffusion at that back end. I've got a lab area, a measuring room, and it's really comfortable. Although my measuring space is quite small, and it sort of works for doing some of my measurements. But one of the things I often talk about in talks is, what do you have to do to get accurate measurements? And I'm a real stickler for getting accuracy in measurements, because if we're ever going to talk about listening versus measurement, and which is important, which should you do, what represents a good measuring speaker, then you need to know how to measure accurately. And there's no substitute for having a large space in which to measure, whether it's anechoic space. Small anechoic chambers don't work well enough at low frequencies. Small rooms don't work well enough at low frequencies. You need large space. If you go outside, you have problems of noise at low frequencies. Everything always concentrates to low frequencies. And there's various techniques you can try and use to get around some of these limitations. but they only work over limited frequency ranges. So what you're hoping for is each special technique has some overlap region with the other technique. So you can see, oh, those curves look the same from here to here. Therefore, I can overlap them and stitch one to another. Well, often they don't have sufficient overlap region for you to be confident in what they're doing. And so my room here, for this particular speaker I'm designing, I knew there was a technical issue in the speaker, right in the middle of that range where I could not measure accurately with either or any of the techniques that I'd got. So the only answer was go to a large space. And I did actually try, I thought it would be interesting to give people a tutorial on the problems of measuring. And so I thought, I'm going to carry everything up to the roof of my condo, my whole measuring system. And I've got this tripod array that you can wind the speaker up to about 15 feet high, so you can get it well away from the ground. But there was wind noise. And after an hour of doing all these whoop, 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 hoping nobody saw who it was and where it was coming from, I hear someone approach me on the roof of the building, and we wondered who was making those noises. They determined it must be coming from the roof for some strange reason, and it was me. And then, we can hear that down in our apartment. It turns out that MoFI has a distribution warehouse in Vegas, and it's a huge brand new facility. And when we went to visit the first time and have a meeting there to discuss, some of the design concepts, I got a tour around. I'm looking at it, and I see at the back end of the warehouse, there's this totally open area, no shelves, nothing really in there. And I say, is this kind of always empty? And they said, yeah, pretty much. We use it as an overspill area when we get a truck coming in and we have to unpack things, but so it's mostly always empty. I said, could I use this for measurements? Because it's like a 28-foot high ceiling, and there's a area about 50 foot by 50 foot that has nothing in it. I think this would make for some good measuring. So I'm actually, yeah.
We have a question. Steve, I've had a question. What's your measurement rig? So describe what you use for measuring.
All the microphones are B&K microphones. I collect, I'm a collector of test equipment. I have so much B&K equipment. I have about 20 or more B&K microphone capsules. I have about a dozen microphone preamplifiers. The microphone capsules range all the way from 1-inch capsules up to 1/8 inch capsules that can measure out to 100K. And that's very useful for each one can go higher and higher, but not quite so low. So again, I can cross-check and recalibrate all my microphones whenever I need. And then for creating the test signals, I do that on the computer, and I use REW sometimes. I use all sorts of other impulse programs to test them and do the correlation. So, but whenever I measure, I always measure the input volts at the speaker terminals and reference to that, so that I've always got a true transfer function. SP out for voltage in, and so that's now I have a tower that's 14 foot high that I can put my speakers on, and a microphone that's on a stand at 14 feet high, which is entertaining, getting a 50-pound speaker 14 foot high. I have this crank up thing, so I can lift the speaker. It drops down to about 5.5 foot high, so I can put the speaker on, and then you crank it up to the 14 foot high.
Like a scissor lift.
No, it's actually, it's one of these, they use them for lighting rigs at concerts and things. You know, all these tubular frame lighting things, lighting bars. That they have these wind up jacklift, not jacklift, but it's a telescoping tubes that almost, they kind of lift themselves by their own bootstraps. It's really odd that the way they go up. But it's still a bit scary once you got your £50 speaker up 14 foot high and you're stood underneath it. But more recently, because I use that as a portable thing, I built a permanent 14 foot high stand. So now you have to carry the speaker up a ladder and kind of put it on top of the stand. So that's scary. I don't do that myself. Let somebody else carry that. I'm too old to carry £50 speakers up a ladder. So it's a great space where the biggest problem with measuring, if you don't have just one system that measures just in one sweep, then you're always questioning, did I apply all these different techniques correctly such that they represent correctly each frequency range and they overlap sufficiently for the other technique in the other frequency range? So you always think, yeah, I've got a response, but is it the right one? And often you've done it on individual drive units to get there. But once you combine them through their crossovers, you can't use some of those techniques. And you'd love to be able to stick the final speaker up and go whoop, and that's what it does. But you can't. Well, now I can in this large space. And I even developed a combinational technique, which is sort of ground plane measurement, but isn't. And so now I only have to put the speaker on a 3 foot high stand, but the microphone is a ground plane microphone. And that now makes it much easier. So it's fortunate to have that. It does mean I have to drive to Vegas to do that, but that's not so bad.
I think we had another question from Steve. Do you have a recommended speaker distance from adjoining walls regarding SBIR? Steve, you can ask your own questions too.
I'll wait.
Yeah,
actually,
you can go ahead and ask the question.
What you just mentioned was sort of a lead in having to do with design, because you can design a range of speakers with a particular concept in mind that I'm not going to do porting, I'm not venting, I'm not doing this, I happen to be a Wilson guy, so I'm all about time alignment and all that kind of crap. So, but you obviously have your own philosophy about what do I develop, what do I design for, and then where's it going to fit? Because customers ultimately have to buy things.
Yeah, well, as I said earlier, I have to be conscious of how people are using the speakers, because I'm going to be designing both technical parameters and listening. And so I have to have a space in which to listen, and I have to have music to which to listen to. And they all interact with each other. And what's the truth? And the basic answer is my truth.
And it's your room.
It's my, yeah, it's me. It's all about me, the usual answer. The interesting thing is I make my own choices, but I also have to be aware of the spaces in which people will listen. And it's very interesting. I love some of the sites where people show their listening rooms, because you look at those and going, why am I wasting my time? In one respect, because some setups are nothing you would ever recommend. But then you have to realize that some people have very limited choices of where they can put the equipment. So you have to decide, should I make compensations for that when I'm designing. But then will that compromise what you can do if you set the speaker up optimally? And this is always the difficulty. Do you end up chasing your own tail? Because you're trying to please too many different choices. And so in the end, yes, I'm aware that if you put it too close to the wall with a rear firing vent, maybe you build up too much base energy in that room. And we actually answered that question at ELAC because the original debuts had rear firing vents. The second generation had front firing vents. So we'd get people saying, how close can I place the speaker to the wall with a rear firing vent? And the answer is, it depends. It depends on your listening distance and what the room characteristics are. And there's a certain, it's not that you ever really choke off the vent, but you do get an imbalance between the vent output and the front driver output. So maybe you need to move them a bit further out from the wall. So we thought, okay, let's get rid of that problem. Let's put the vent on the front. And one of the reasons you put it on the back is that any noises that come from the vent have to diffract around and bounce off the wall before they get to you. So they're less obvious. When you put the vent on the front, chuffing noises become more obvious. If you've got internal standing waves in the box, they come straight through the vent. They become more audible. It does cool your feet in the summer when it's blowing. I mean, once you get vent overload, you just get high velocity air blowing. And literally, if you're listening in the summer and you're wearing shorts, you realize that, oh yeah, that's my front vents now. The drapes used to move behind it in the past. Now the hairs on my leg move because of the air coming out the vent. But guess what everyone said? Well, they don't seem to have as much space as the first versions, right? So you can't please everybody. So who do you listen to? So that's why this idea of I try and just make a decision for myself, what I think works best, and then just trust that there'll be enough people that can set it up in the best way and accept that, it doesn't matter what I do, certain locations of the speaker that people are forced to use will never represent the best they can get out of it. And those people are stuck with it unless maybe they can apply some EQ. And I'm not a big fan of kind of room EQ in the ultimate sense, but I accept under certain circumstances, you have no choice and it will work better than doing nothing. And then, in measuring, I've also got to determine what the influence of a rear vent is compared to a front vent. And I actually faced this problem just recently, because with a small speaker, the rear vent is actually distance-wise not that much further away from you than the front driver. So you've got what the actual energy, the total energy radiated by the vent is, the total energy radiated into the room by the front driver is. But you've also got the SPL, and SPL is distance dependent. Obviously, SPL drops with distance. So if I measure too close, suppose I measure at 0.5 meter away, that's 1.5 foot for you Americans, not for the non-science Americans, just saying. So if I measure that close, I'm much closer to the driver than I am the vent, because the vent is an extra 8 inches away. And so the SPL representation that I get at the microphone of the ratio between driver and vent is wrong. So I really need to measure 1 meter or 2 meters or 3 meters to be in the true far field. But trying to find a space where I can measure at 3 meters and have no influence from all the energy coming from the walls, I can't measure at 3 meters so accurately the very low frequencies. So it's kind of this perennial problem of you need space in order to measure a speaker. And I faced that with this speaker because I'd been making some judgments based on near field techniques for low frequencies. And then the first time I got this large space in which to measure, and I was measuring at a meter, I'm thinking the bass to mid balance seems wrong. And not what I'd calculated. You know, I'd done all my driver measurements, I'd calculated my crossover, I'd got what my system response should be, I built the system, I take it to my large listening space, and that measured curve does not match my simulated curve. And I know it should. Whenever I design things, if I build a crossover to match my simulated crossover, it will generally be closer than half a dB. And I know that if I then take that measured crossover response, multiply by each driver response, add them all together to get the system response, it will be within about half a dB of my simulation. And this wasn't. And I think, oh, what's going on? And I suddenly thought, maybe it's because this speaker is much bigger, so the drivers are further away. The vent is further away than the driver, sufficiently so that it doesn't add in the correct ratio. So I did some calculations, and the calculations showed that, yeah, if I'm using that measuring distance, it's going to appear to be about 1.5 dB lower than I simulated. And the problem when you're listening to bass balance, 1.5 dB is a lot. We're very sensitive to small changes in bass level. So 1.5 dB is a lot. And so I decided I've got to have to start measuring the speaker at larger distances. And so one of the ways in that space I could do that is make a ground plane measurement. So you put the speaker on the ground, you put the microphone on the ground. And the nice thing is the ground is solid polished concrete. So it's the best surface you can have to be fully reflective at all frequencies. So perfect conditions. And then it means there's no surface closer than 28 feet. So I've got about 40 milliseconds before any reflection will arrive. Now, when you measure ground plane, you're effectively measuring 2 speakers stacked on top of each other. So we've got 2 drivers and double the baffle area. So you have to make corrections for that. So it's still not perfect, but at least it enabled me to get down to much lower frequencies accurately, and verified that my bass to mid balance changed as I moved out further distances. And I could get out to measure at 3 meters with very good low frequency accuracy. So it's finally able to fine tune the speaker. Because I heard, you know, if I listened too close, I could kind of hear that, but enabled me to rebalance the speaker and get it sounding more like I wanted it to be. So,
Andrew, we have a pile of questions in the chat. Can
you
see them? Are they here? Because there's so many here now.
That if I turn them on,
click on the chat, and you can see the questions if you want to.
So,
because some of them do have to do with what you're talking about. If you want to address some of these.
Yeah, that thing, Steve, about what was SBIR? Do you have a recommended speaker distance from adjoining walls regarding SBIR? Oh, speaker
boundary interference response.
Oh, okay. All right. You know, I tend to keep speakers about 1 meter away from the front wall, or the wall behind the speaker, which is what you're facing, the front wall. Some people call it the back wall, and yeah, it's at the back of the speaker, but it's the front of you. So I call it, for me, it's the front wall. Yeah, I accept that the bass is going to build up a bit. Well, it's actually interesting. This question of what do you hear when you get closer to boundaries? Because when you look at the wavelengths at 50 hertz, we're talking about 20-foot wavelengths. So when you're 1.5 feet or up to 3 foot, you're still very close to the wall compared to the wavelength. So you shouldn't expect to hear that much difference due simply to boundary reinforcement. If I listened outside and I put it close to a real wall or 3 foot away from that rear wall, I get about the same amount of very low frequency reinforcement. But it doesn't sound like that's what happens when you're in a room. And the reason for that is it's all to do about how you couple into room modes. Because when you're close to an antinode or node, the coupling efficiency into that node changes rapidly with distance. So a few inches can make a huge difference. And so I always like to keep it away from walls. And if I have to get close to sidewalls, that's when I recommend, especially with concentric drivers, towing the speaker in to cross in front of the listener, because you're going to minimize sidewall reflections. Now, with a well-performing off-axis response type speaker, like concentric drivers are, for example, the sidewall reflection isn't quite so critical, because at least it has a similar-ish tonality to what the direct response of the speaker is. So it blends in more easily. But my preference always is set speakers up rather wide in the room and then tow them in to firm up the center image. And so now you can get a huge expanse of sound, but still with very strong specificity of images. Listening rooms always have flaws. How do you deal with that for both design and measurement? Well, I don't, because you always have them. I mean, it's you can't if it's the simple floor bounce, it's always there, whether you're listening to real music live, whatever you listen to. The only difference is where the dip frequency is a bit, because you're either sat down or stood up. Every sound you ever hear always has pretty much floor bounce. It's programmed into our being. And so, it's going to be there. You can't deal with it. And the tests that have been done to show importance of particular reflections, we started doing a lot of this back in the days of KEF. I've probably mentioned this in the past, but we did this European project. It's a combination of Bang & Olufsen, the Technical University of Copenhagen, and KEF to simulate a room under anechoic conditions. So the Technical University had this huge anechoic chamber, and we hung 30 concentric speakers in a 3-meter sphere around the listener, both above and below the listener position. Then we designed a computer program that you could calculate the off-axis response of any speaker source in any direction and calculate what the sound of each reflection in each boundary would be, and the reflection of a reflection. And then you grouped any of those into 10-degree angles, because that was the audible acuity for sound sources in those kind of directions, and fed them through each of these 30 speakers. So you could simulate any room you wanted with any absorption characteristic you wanted, and then turn them off or on. You could turn off the floor and observe the effect, turn off a sidewall, turn off the ceiling, and start to determine which were the important reflections and what characteristic they had audibly. And then Floyd Toole picked up on that and continued that with all his published research. So it just turned out the floor wasn't the primary factor. It was sidewalls and ceiling for some reason. So yeah, floor exists. Apart from putting a rug on, which only deals with scatter of very higher frequencies.
So how does the measurement of a speaker change if I'm measuring it on your 40-foot pole versus putting it on the floor?
So what you'll see in a room is, well, so typically the floor bounce produces a dip in response in the 200 to 300 hertz region. It depends on your listening distance and on the speaker height and listening height. Now, listening height is pretty consistent. It's about, ears nearly always at a meter high. But it'll be in that region. Well, there's still lots of room resonances in that region. So sometimes it's difficult to pick out. But if you do a smoothing or a spatial average of a number of listening positions, the spatial average you typically do at listening height. And so there you'll average out some of the particular room modes due to longitudinal and lateral, and the dip from the floor bounce will tend to stay there.
I was expecting that there would be a big base difference between operating into 2 pi steradians versus 4 pi steradians.
But you're not operating into simply 2 pi steradians.
Okay, that's
right?
too simple of you. Okay.
Yeah, it's like I said with the example, if you just get a speaker close to a wall when you're outside, let's say outside in the snow, because snow is a good absorber. So we've only got the wall. You've got just a very simple relationship between the speaker and its boundary. When you've got, say, that wall behind the speaker and a wall behind you, so you can now get standing waves, you got a very quickly, you got a much more complex relationship between speaker position and the boundaries, either the speaker position with respect to the boundaries or your listening position with respect to the boundaries. Then you add the sidewalls, then you add the floor back in, then you add the ceiling. Hugely complex. So it's this idea of it's simply a 2 pi effect is really not there. And we found historically that the most preferred sound balance from a speaker, from a technical measurement point of view, is give it a flat, free field response.
Okay, flat free field is what you shoot for. And
that's what we shoot for, yeah.
It's up to the listener to put it in the right place.
Yes. And you hear about this effect of room gain, yes. Right? And a lot of the earlier room correction algorithms shot for a supposedly flat response down to low frequencies. They always sounded thin. I always turned them off. And even Paul Barton, when he designed his headphones, he designed them to have room gain. He didn't design them to have a flat response at low frequencies. He had some gentle bass lift, because that's what we've found sounds either right or correct or most enjoyable or most natural, whatever description we want to use.
Right because we listen to hi-fis more than live music?
Could well be. And this gets into that great question, which would take 2 or 3 hours of me talking in itself, of what is correct? Is it the measurement? Is it our listening? Well, listening to what music? How was the music recorded? How do we possibly know with any recording we've got what it ought to sound like? Is there a single representation vision of the producer as to what that sound should be? it's a whole minefield. But basically, my way round that, as I've said many times, is about
So
me.
you've
If
given up
I
on
like the
high-
sound of it in
You've
my
given up
room,
on high fidelity. I mean, where fidelity.
I like that. I've given up on high fidelity. Yes. And I've gone to, if you like what I like, I'm in business. Yeah. Have you designed acoustic suspension speakers? Yes, I have. But most of them are vented. Even my most expensive speakers, my TADs, are now $150,000 a pair, can you believe, are vented. I'm not of the opinion that the only correct base loading technique is acoustic suspension. I can explain why I think there's some degree of misguided thought as to why a second order high pass suspension system is better, but again, that's a long technical talk. Have you considered using the clippable measuring system? Yeah, no one will ever buy it for me. I mean, the minimum buy-in is $40,000, and so if you look at but this is actually a very interesting point. If you look at what's his name from Audio Science Review, someone shout out his name. Who runs Audio Science Review? Anyone? Amir, Audio Science Review. He's spent $100,000 on his clippable system. Erin Hardison has spent $40,000 on his. And I know Clipple, we worked together at Harman. Well, we both worked at Harman at the same time. He was working with Floyd Toole. And I look on that system as it does not measure the far field response of the speaker. It synthesizes the far field response of the speaker. Because it measures in a room, it uses complex mathematics and near field measurement techniques to eliminate as much as possible all the interfering effects and the anomalies that you get when you come in near field to tell you what the far field response is, but is not measuring the far field response. So it's good for people who, it's an expensive way of overcoming some limitations of measuring in a very small room, that can, and it can do a lot more than just measuring frequency response, obviously, but it's can't necessarily replace the simplicity of making a true single sweep far field response. And that's partly my response based on no one will ever spend $40,000 for me on a measurement system. So experience with DSP correction like Dirac. So I've only ever tried using relatively simple DSP correction techniques. I've never been enamored with them. I remember with being at Pioneer, I was there when Pioneer first introduced DSP room correction into their receivers. And we were one of the first to make that widely available. And I go in one day, it was a CEDIA event, and we got our measuring booth. Sorry, I'm not measuring, our listening room, part of the big booth we had at CEDIA. And I walk in, and all the product specialists are setting up the room. They got my Pioneer EX speakers, S1 EXs, and they're playing with this receiver, and they're doing all these sweeps. I'm walking in, what are you doing? And, oh, this is really cool. We've this new receiver that we're launching into the market this year. it's got this ability to measure the response of the speaker in the room and apply all this correction to it. Really? Show me what it's doing. And so they started doing all these sweep tones, and it was changing the sound. And going, are you able to show me what it's done? Oh yeah, we can pull up the graphs to show what its measurement was and what correction it's applying. And I look at this kind of correction, and it's doing it over the whole frequency range. Like, why do you feel you need to change the frequency response of my speaker over the whole frequency range? And then I looked, and they showed me the EQ it had applied to the left speaker and the EQ it applied to the right speaker. They're completely different. I go, you can't do that, especially above 200 hertz. You would never do. Why would you possibly think you should be doing that? This is silly. And it was in the very early days when even it was being done with basically parametric EQ, and they didn't have much parametric EQ at the low frequency end. So they were trying to do some correction that was way too broadband and was pointless in my view. And so I'm telling them, turn it all off. Let's listen to it with it off. Oh, that sounds much better. Just then, the guy who was in charge of the product specialist comes in, or he'd been overhearing this conversation. He says, oh, hey, Andrew, how are you doing? Hey, I'm fine. Can I have a word with you outside? So he walks me outside. He says, why are you telling all my product specialists that this is useless and they shouldn't be using it? This is our major selling feature for this season. I've just been instructing them about how cool this is and no one else has got it, and you're telling them not to use it. So I was always the one known as the one who walks into the room, and I said, is there a cancel button on this? And I always would push cancel. So if you've got multiple speakers around a room and a very complex kind of DSP system that can apply correction signals to the other speakers for that particular one, then you can begin to correctly, in my view, start to treat acoustics, room acoustics. But if all you're doing is applying simply EQ to the primary speakers, there's a philosophy that I have that says we design the speakers to have a very nice, good response before we put them in the room. And what we hear in the room is part of the direct sound, the first arrival, which is the pure sound of the speaker. And we have all the later arrivals, which are the sound of the room returning to you. And the ear has different sensitivities and in different frequency ranges to how it responds to the direct sound and how it responds to the delayed sounds. And it depends on how delayed and what direction that delayed sound is coming from. And it has this complex processing to give you its interpretation of what you hear of the sound. What the simple DSP systems do is, in order to change the late arrival sounds, their only recourse is to alter the direct sound. But the direct sound was correct. So why are you corrupting the direct sound for the next direct sounds that come in order to make something fix the later sound that's about to come at you when the direct sound has already moved on to a new sound? Sounds crazy to me. Now, there is an integration period that the brain has. So there's a partial argument against that philosophy I just espoused, that, well, over a certain time period, the brain collects all those direct and delayed sounds and fuses them into one. So you could say, okay, that gets over my objections, because over that delay period, over that frequency range, maybe you wouldn't tell that you've corrupted the direct sound in order to fix delayed sounds. So, you know, you could have a valid argument against that philosophy. So I keep both thoughts in my head. But basically, if you've got a problem with the room, fix the room. You're never going to get better than fixing the room. But then that also addresses that thing I said earlier, that you look at some people's rooms and you think, doesn't matter what I do, you can't fix that room. I can't physically fix that room. So maybe the only recourse is use some EQ, and you can make it better. You'll never make it as good as if you put it in a good room, but at least it'll be better than just leaving it to a really bad room.
What are some of the advantages and disadvantages of near field listening so you get more of the direct sound?
Oh, yes, that's the very simple fix for a bad room, near field listening. Unless the port's at the back, like I just talked about. I mean, once it's in a room, not so bad, because at least you'll get an energy integration at the lowest frequencies. And so, but definitely from most of the sound you get from the room, and particularly the higher frequencies where you've got reverberation coming in, it'll be much better if you do near field listening. And I like to think of, you know, when we talked about the early days of digital, and you've got all these anomalies coming in, and digital seems to never decay. It decays and then just sort of disappears. It doesn't smoothly decay all the way. So then we have to use dither, and then although you got noise there, you can hear the real sound decay. Even below the measured noise level, you'll hear the sound as it decays down when it's perfectly dithered. But there will still, once you introduce noise into a system, there's a level below which the noise will mask the detail in the signal and set a limit, a threshold on how much detail you can hear from that system. That's why headphones sound, even simple headphones, sound so much detailed than a lot of even high-end systems, depending on the room, because there is no room. That room reverberation is like a noise level that sets the ultimate masking threshold for that fine detail. And so a highly reverberant room will set a higher masking threshold. And so listening in close fixes that. And also, you know, wall mounting speakers. We actually did an interesting experiment at KEF, getting back to walls. We put a speaker on a speaker stand, reasonably high, and you could listen to it like that. We then moved them backwards until the speaker was just in front of the wall and showed how bad that sounded. But then we took out the wall plate and we got a cutout in the wall exactly the size of each cabinet. And then we just kept pushing the speaker back until it was now flush in the wall, but switched in EQ, where getting back to that 2π thing, this was now sort of a true reflection of what 2π is. It totally removes baffle step. And so we re-EQ'd for that. And what was interesting is, as you move the speaker well out in the room, had a great depth of field, let's say, of the sound field.
It's an English
You move
Yeah.
it close to the wall, and that depth of sound gets foreshortened, especially since you can see the wall. It just seems that there's no sound further away from you than where the wall is. Then once you've truly flushed it into the wall and removed all baffle diffraction effects, that depth just comes back. The sound appears to be coming from way, all the way back behind the wall. Very interesting. So in wall can actually be one of the best ways of hearing a speaker as long as it's not just a cheap in-wall speaker screwed to the wall, so the whole wall starts vibrating. You know, if it's a true built-in system done in the right way, it can be a very good way, alternative way of listening to the speaker, except it removes the freedom of trying to compensate for standing waves in the room, because you're maximally energizing every standing wave in the room once you've put it literally in the wall. Who will be manufacturing the MoFI drivers? I think I'm going to tell you that. It's going to be, the first ones are going to be built in China. I've got some very, very good manufacturing in China, and always have. You know, it's.
These are all my questions, by the way.
Are they?
Oh, well.
He's laughing at
Just
The
muted. I'm so sorry.
so quality of manufacturing in China can be excellent as long as you're in control of it, and always have been. And I have a person that living in China close to the factory, that's lived in America for a couple of decades, know them very well. They moved back to China. They are my kind of liaison with the factory, in, you know, to talk with them every night about what's going on, get, you know, the design issues sorted out and the understanding of what I'm trying to achieve. So it's like my own engineering assistant, but based in China. So I have perfect trust in the quality levels I get out of China. And in fact, the manufacturer that is doing all the cabinet and final assembly used to build all the TAD cabinets. And so I know they're good, because if they can build TAD quality with all our Japanese QA engineers going over and inspecting the cabinets, then I know I've got full faith in what they can build. I remember once with TAD, in the very first TAD speakers we were building, the ones with the laminated cabinets, they were being built at a, although all the final assembly was done in California, the cabinets themselves were built at a factory in China. Not this one, but the ones that, the final ones, we build them here in California in a Pioneer facility run by Pioneer quality control engineers from Japan. We'd ship them out to Japan, and then every once in a while, Japan would say, oh, we found this flaw in the finish that doesn't meet our quality level. I'm going, but we're manufacturing to your quality level and inspection by your people over here. So how do you mean it can't meet your specifications over there? They're supposed to be the same specifications. And so after a while, they'd gathered about a dozen or more speakers that they said failed their levels. So Andrew, on your next visit over to Japan, can you go over to QA and they'll stage all these speakers for you to examine and see what, because trying to photograph some of these flaws in a high gloss finished cabinet, it's so difficult to get a good photographic representation of what these flaws are. So go over there and they say, okay, these are them. And so I start looking all over the speakers. I'm looking and looking and looking. And in the end, I say, can you show me what you mean? Can you show me what the flaw is? And they'd walk me over and they say there, and they'd point to it. And I'd look and I look and I look. Oh, really? That's what you're rejecting it for? It was so specific and such a small little detail that I would have never thought to say reject, but they were. And so when I realized that this factory was the one that produced the cabinets that did meet Japan's quality control, I was going, yeah, that's the factory for me. And it's turned out really good. Oh, Laurie's asked, how many feet are considered near field? The technical answer is depends on the size of the speaker. So you need to be far field is when you're a number, it depends on the wavelength of the sound, the frequency range and the size of the cabinet. The bigger the cabinet, the further away you need to be. As you get in close, you'll change the sound balance of the speaker at the lower frequencies. So you'll perceive mostly a lift in bass. No bad thing, we all like that. Depending on the driver technique, if you come in too close, you'll sense some lack of melding of the two drivers. Say you got a woofer and a tweeter, they won't seem to integrate so well together. Or to find the exact listening height at which they do that is much more critical, because the subtended angle between the ear and each driver is a much greater angle. And since the ear is sensitive to the height of the sound source, then you're more aware that they got sound sources at two different heights that are both representing partially through crossover range the sound, and even beyond the crossover range. So it's sort of one of those, I'm wriggling out of a specific precise answer, in that there is no one distance at which near field is considered, but it's partially related to wavelength and size of cabinet. But I would say that certainly when we're talking about near field with respect to how close to listen to the speaker in order to eliminate or partially eliminate some of the effects of the room, then I'd say 3 to 4 feet would be near field and would be a good distance to listen from to help ameliorate some of those room effects. What are some of your favorite amplifiers? I'm not so sure about favorite as opposed to what I've ended up using typically. I mean, I have a number of different amplifiers and I've used different amplifiers through the years. It would be remiss of me to not say my brother's amplifier that he designed for Benchmark. So the Benchmark AH2 was designed by my brother, so that has to be one of my favorites. But I listen to both regular solid state class AB. I've used Pass Labs amplifiers in the past. I've used class D amplifiers, the ELAC one that Peter Mannick of Constellation designed. I've got a VTL tube amplifier. So they all sound different. And I have all these different amplifiers because I have to recognize that different people will listen to my speakers over different amplifiers. So I've got to be aware of how they influence the sound of the speaker. But I also know, particularly with tube amplifiers, there's always going to be great variation between different tube amplifiers and how they interact with the loudspeaker as a load. Because most tube amplifiers have a much higher output impedance than most solid state amplifiers. And so just the frequency response of the speaker, regardless of whatever properties tubes have compared to solid state, there is a very simple thing that most tube amplifiers have, and that is they alter the frequency response of the speaker. That's not magic. That's not anything that's kind of metaphysics. It's just you measure the frequency response of the speaker when driven by a typical tube amplifier compared to a solid state amplifier. It will have a different frequency response over the whole frequency range, not just in the low frequencies. And that will be determined simply by the impedance characteristic of the loudspeaker. So I could design a speaker to have different, let's say different crossover slopes or a different topology of crossover, and I could give it pretty much the same frequency response, even off axis, but different topologies of network. Although they will have the same electrical response into that load, they will have a different input impedance. And so that speaker, once put onto a tube amplifier, would have a different frequency response. So that's, you end up chasing your tail in the design process if you're doing that, because you make an intended change to the crossover to change a particular aspect of the frequency response. But along with it, you get an unintended change, an unintended consequence, that the frequency response is altered in some other way as well as the way that you wanted. And if you're not aware of that happening, you'll build this, you'll listen to it and you go, wait, that's not what I thought that change in frequency response would do to the sound of the speaker. And it's because some other things were happening. So I tend to typically design around low output impedance solid state amplifiers, and then listen and go, oh, so that's what the tube amplifier sounds like. Okay, I get it. But unless I design a speaker with absolutely constant impedance across the whole frequency range, and we did that at KEF, the KEF 1042, we specifically engineered every aspect of that crossover to not only give us a flat frequency response, but to give a completely resistive, within plus or minus half of an ohm, impedance from, let's say, 50 hertz to 20K. It's about the only speaker that's ever had that over such a wide frequency range. And what that meant is, no matter what amplifier you used with it, it would always maintain the same frequency response. And because that impedance was resistive, it had no weird phase angles. So you had no oddities in terms of peak current levels, depending on certain combinations of musical signals that could demand high current requirements from the amplifier. Everything was absolutely known. If you knew the voltage, you knew what the current was for any type of signal that you put in.
Was that effort misguided or wasted?
So I would say not misguided from the point of view, it was absolutely understood what the current requirements were for that speaker for any signal you put in. And so there's two aspects to that. What is the peak current you need from the amplifier? But also, when you've got a large phase angle, you'll find that the amplifier requires both peak voltage and peak current. So peak voltage across the output device at the same time as peak current is flowing through the output device. So you stray into the non-safe operating area of that output device very quickly. And so you can exceed that safe operating area and blow up the amplifier. So in the old days of high-end hi-fi, a lot of manufacturers didn't give a hoot about what the phase angle of, worst phase angle of the impedance was, or the minimum impedance. Remember all those Infinity speakers with 2 ohm impedances, early Wilsons with 2 ohm dips. 2 ohm dips combined with an awkward phase angle meant that now we started producing these mega amplifiers, you know, 100 watt notional amplifier that could drive 800 watts into 2 ohms because it had to have that current capability. And then the question is, well, do I need to do it as a continuous sine wave capability? Do I have to dissipate 800 watts equivalent with that amplifier all the time, or is it only for a short time? So do I need high dynamic capability, but not long-term? It makes it so difficult to guess what that amplifier has to be designed to cope with. So we said, if we just make it 4 ohm, and we were saying to the dealers, now you don't have to sell these mega amplifiers. And the dealers say, don't you dare tell our customers that. You can't tell our customers that. We love selling mega amplifiers to go with that difficult speaker. We welcome it. So misguided in that sense, absolutely. Misguided from the market or the dealers, yes, absolutely. So, but it meant the crossover network was about 30 or more components in order to do this. And of course, oh no, simple is best. We only want a capacitor or a capacitor and inductor at most. Any complex network screws up the sound. Well, you know, the 1042 was one of the best-selling speakers of all time. And at one point was the best-selling imported speaker in America of all time. So, you know, the marketplace maybe didn't know how complex that crossover network was, so they couldn't get fooled into is it complex or not. When we did the 105.3, this was the last speaker that got designed before I became chief engineer. It was designed by our old chief engineer who actually defected to B&W. How could he? Mike Goff. So he had to get that one finished before he left. And it ended up, from memory, it was close to 50 components. And all this, trying to get the right adjacent slopes so they add up to give the right phase angle to give a constant impedance across the transition region. And then you got to conjugate each drive unit. And it just goes on and on. And he came up with such a complex network. I don't think I ever fully understood the details of everything he'd done to do all of that. But yeah, it went into production and that was his last contribution. And I don't think we ever did that again. Just it's so expensive to do. And Raymond Cook would always ask us, why are you solving all these problems that people never knew existed, and if they did, wouldn't care about? Why don't you solve problems that people care about? And it was a valid critique of us. So I started to kind of follow his philosophy. You know, what do customers really have problems with? What do you wish the audiophile market would love active speakers more? Absolutely. So you could design the speakers with the amp that will drive it. Yes. My last great attempt at doing that was the active speakers for MELAC. And I love that speaker. And everyone who's heard it loves it. But for whatever reasons, once again, limited sales. And I even tried to engineer it in a way that would meet a number of different market segments, in that it had no DSP in it. It wasn't like a KEF LS50 active, because apparently some people don't like digital. I've learned that even more these days. And I always thought that the idea of doing DSP crossovers, although DSP crossovers are very, very powerful, sometimes you don't really need that, or for crossovers for a speaker. Or if you do need that, you've done something wrong in the drive unit design, right? So just like with the room, fix what the source of the problem is rather than what the result of the problem is. And so it became, because if I need a DSP crossover, then it's fine fed directly from a digital source, but lots of people have got analog source. So now you're going to digitize the analog source to go into a DSP crossover to turn it back into analog to go into the drive unit. That seems crazy. So if I can do it with active crossovers or active analog crossovers, and if that can do an adequate job because I'm designing the drivers and I've tried to do my best to get drivers that need not too much EQ in them, then won't that work? But then I can add a D to A in there to give me wireless connectivity, so that you know, for people who do have digital sources or want simple ways of connecting to it, I can add a box or either wireless or wired digital input. But it gives that expansion capability for newer listeners who are not audiophile diehards, but are people who want just this wireless speaker that any source can talk to. So I split it in two parts that way. And it sounded great. But once again, you've got the problem that either through tradition of doing things, or just the fact that, okay, if I've already got my amplifiers that I like, I've already got my speakers that I like. If I want to upgrade the speakers and upgrade to an active system, I've got to not just change the speaker, I've got a redundant amplifier. And so that becomes, your upgrade path becomes that much more difficult, and you've lost choice. Well, how do I know that Andrew knows anything about amplifiers? So how do I know what choice of amplifier he's put in there? You know, what if he'd have used a tube amplifier for his active system, to take it to an extreme? Or what if he'd, and I did make it, they were not switching amplifiers, not as a trying to say switching amplifiers are bad, just that in the marketplace, switching amplifiers had still controversy about them. So let's not even go there. Let's go to basically class AB amplifiers. But you still got, well, you know, maybe, you know, why did Andrew choose that particular class AB amplifier rather than something else? And my answer would be, why does it matter? Because surely I'm giving you an experience. I'm the designer. I've set it up. I've chosen the amplifiers, just like I do at every show I go to. I choose an amplifier. It's not that I've got a range of loud amplifiers for you to come in and say, can I hear your speaker with this amplifier? No, I give you one choice. It's the amplifier I've chosen to give my demo. And you listen to my demo and you go, I like that. So all I've done is taken it one step further. It's not like I've designed my speaker and I've designed my drivers and you come in and go, I wonder if what your debut speaker would sound like with a Dyne Audio tweeter. You don't do that. You accept that I've made my choices. I made my choices of type of crossover and crossover components. And you listen to the system and you go, yeah, I like that. I'll purchase that. So the amplifier, or the crossover built in, is just adding one extra component that I've integrated in to give a sound that I could not have got at the combined price of a separate speaker and a separate amplifier. I could not have got that sound quality to match what I can do if I make it fully active analog, let's say. And you can still play with your preamp. You can still play with your turntable, your DAC, every other component in the system you can still play with. But we've all been led to believe that we want total freedom of choice. And so there's still resistance to active speakers. But pretty much any engineer will tell you, any speaker engineer will tell you, yeah, I'd love to be doing active speakers. So, and I will still keep trying. It won't mean that every speaker I ever do will be active, but I'd like to try. And in fact, most studios these days are active. So most of what you hear from the studios that made your records are listened to on active speakers. So,
Andrew, if I may ask another couple of questions before you go. One, do you have by chance a preferably chronological listing of the companies you've designed for and models you've designed over the years?
Yeah, so back to that early conversation about how many, he's jumped ship again, that people were saying on the internet when I left ELAC. So that one's easy. It's 5. This is the 6th company I've ever worked for, right? So,
Okay.
yeah, went from university to postgrad research, both in hi-fi and then another 3 years in active noise cancellation. But then I joined KEF. So I did KEF, Infinity, Pioneer / TAD. So that's either 2 or 1, depending how you look at it. But let's say it's 1. So it's KEF, Infinity, Pioneer, ELAC, now MoFI. So the total answer is 5 or 6, depending on how you look at that, in over 40 years. So it's not that many. Now, the number of models of speakers, of those that I can even remember, are prolific. So that list would take a lot longer to compile, because I did quite a few at KEF and then a hell of a lot at ELAC. And so there's been a lot of speakers.
So Andrew, my impression of kind of ELAC versus MoFi, and correct me if I'm wrong, ELAC, you were like a speaker designing machine. You were under pressure. You had to you produced a lot of different speaker models. Now MoFi, it seems like this is kind of more the true Andrew Jones speaker you're designing now. I mean, is this one like it's going to be more signature series?
Well, in the sense that I've had they're giving me almost complete total freedom, although they have a vision of, their total philosophy to sound. They're not questioning what my vision of the speaker should be. So all the design concepts, all the sound that I'm getting from it, I'm totally my decision. And they're loving what I've done. One of the comments was transformational. It was listening to it was transformational. I'll take that.
So I presume the only parameters they're setting are, we want to sell it at this price point and we need a certain profit margin.
Yes.
So.
Or should I say, we want a certain profit margin, and then this is, then we decide what the price points are. So I know all of that at the outset. So yes, I got to design for a price, and there's room for maneuver within that. Once you start seeing how it turns out, you go, you know what, I think we should let him pursue that and reevaluate exactly what price point we want to sell, because this is turning out so good that we want to make sure it can get to market and not not go, yeah, but you absolutely cannot exceed what we first said, so you're going to have to make a worse speaker than what you've just played to us. So there's leeway there, and so we're broadly within what my target objective was. But yes, it meets profitability, so that I can continue to work. But yes, it's a fantastic experience, because it is me being allowed to spend a lot of time thinking through even the very first concept of, well, what shall I try to do? I've got a blank sheet of paper. What shall I try to do? And then as I hone in on that and get buy-in on it, then how do I engineer it? What engineering improvements can I make within that philosophy compared to what I've been doing before, to engineer that philosophy better than I have before? So it feels wonderful.
Do you know when or what show you might be first demoing your new speakers?
There's not many left this year. It's possible we might do
Capital
Yeah.
is the one that's coming up.
Yeah.
That's in
Might
2 months?
do. There's talk about Warsaw, the Poland show, but I don't know. That's depends on world events, I think.
Has there been much of a paradigm shift for speaker design with the conquest of audio-visual systems?
Most people who are concerned about audiovisual systems or the big part of the marketplace, spend less on speakers than they used to, I think, because they're spending all the money on all the video stuff. I think the only issue is how you deal with multi-channel surround sound, especially with Dolby Atmos, without having to have all the speakers. I think the biggest paradigm shift is from what Dolby have done with synthesizing sound fields from a minimum number of speakers. What some of the sound bars can produce is astonishing if you're seated in the right location in terms of a surround sound field. So I'd say it's in DSP that is the biggest paradigm shift. Funnily enough, after me saying I don't want to put DSP in my speakers, but in terms of recreating sound fields, you have no choice if you're going to try and do that. Yeah.
I think you had a question about how do you feel about Atmos?
I was one of the first buyers in and with Pioneer to Atmos, and I was fully convinced of it. I was brought along to many of the panel discussions that Dolby held as a speaker designer and a representative of the company that was designing and building Atmos enabled speakers. So I was one of their spokespersons in the early days. I loved what it did. And even on multi-channel music, I never used to even think I'd want to listen to music in multi-channel. But Atmos has changed that. Now I don't, just, but if I, you know, because I don't really have a home theater system. I listen quite simply, just stereo in my, when I'm watching movies at home. But when on the occasion I do listen to a full multi-channel system, the Dolby Atmos works fantastically. Every Dolby Atmos demo I gave through the years at Pioneer, loved what it did.
Okay, Andrew, we have about 4 minutes left. So I think
Okay.
we can do one more question, or you can, why don't you tell us some of your favorite music that you like to listen to most?
So I listen to a lot of female vocalist stuff. I think my all-time, forget about demonstrating, but just from listening, I love Celtic music. You know, part of my British folk music upbringing, but Celtic music, and especially the Irish version of Celtic music, just tugs at my heartstrings. Whenever I listen to it, I feel transported to an ancient times, you know, druids and all that kind of stuff, Stonehenge. Just love it. And there was a recent experience at the Axpona show. They booked a harpist to play down in the lobby, this pedal harp, and producing really beautiful sounds. And then someone had the idea, why don't we take her around to each different showrooms and she can demonstrate in the actual room itself rather than in a busy hotel lobby. And so I was down talking to someone in the lobby and sat, stood right near her. And one of my friends, Andrew, you got to come with me now. And he just grabbed me and took me away from this conversation, which was sort of lucky because that conversation would last hours if I hadn't been dragged away. And it was because she was about to go up to one of the demo rooms to do a demo of, play a harp in the demo room. So there were about half a dozen of us and her with her harp in the elevator going up to the 14th floor. And she played the harp in that elevator. and it was magical. You could say the best elevator music you will ever hear. And then we went into the demo room to be joined by a cellist. I forget his name, but it's the cello guy who often appears at the Montreal show and various other shows. So they did a duet, and it was all Celtic music. And I was just transfixed. And it's so beautiful. And, you know, tears started to fall. And I kind of go, oh, that's so beautiful. And as it all finished, I was walking, oh, that was so beautiful. I really liked it. And so I was an easy mark, because I ended up spending about $150 on a mixture of CDs and albums. So yeah, that's my favorite kind of music.
And then we had a question about top 3 tracks for checking speaker response. And I was talking earlier about your playlist on Qobuz, which
Yeah.
if people haven't heard it, it's fantastic. I listen to it all the time. It still says ELAC, but I guess it's supposed to be saying MoFi now.
Yes, I'll try and get
That's
that
very
fixed.
good. But of those, what are your top tracks?
Funnily enough, for evaluating the speaker, some of Diana Krall. I know it's passé now to use Diana Krall hi-fi shows. There are rooms that say on the doors, we do not play Diana Krall, because it got overused. But there's a difference between using music to technically evaluate what you think the speaker is doing. Does it reproduce that particular track in the way I've always expected to hear it, or the way I want to hear it from this particular set of speakers? And there is no music I use that I don't actually enjoy and emotionally connect with. But there are certain tracks that are more applicable to determining sound balance in particular frequency ranges. And some of the Diana Krall I use for that.
Okay, well, I think we're just about out of time. Andrew, you of course are a wonderful speaker, and we always love having you. And I think you volunteered to come and teach one of our courses for the foundation.
Yes,
about
on
so
DIY speaker building, or how to
Yes,
measure
yeah.
when you're designing a speaker. Yeah.
Yeah,
I'd love
so
to
we're
do
going to have
that.
you up to do that, and then we're going to have you up with speakers as well, because we really want to hear it. And I don't know that we're going to make it to Wausau to be able to hear,
Right.
hear the speakers. So we want to hear them sooner than that. So thank you again, and thanks everybody for sticking around. And this will show up on YouTube if you missed any part of it, or you want to hear it again and again and again. You can watch it as
And
many times as you'd like.
And I
ahead.
should finish by saying, God save the king.
Yep. 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 Here's to the Queen. We appreciated her a great deal. So, but all right. Thank you, everyone, and enjoy the rest of the weekend.
All right. Cheers, guys.
Okay,
Bye.
bye.